Okay, today we're going to talk about function tables, how to create a function table for a given function. So a function table is a table that displays inputs and corresponding outputs for a particular function. So here we have our function f of x equals 2x plus 4. These are our inputs, which is just another name for the x values. There's no difference. So this is just our x values here. And these are our outputs, which are just our y values. You can pick it whatever inputs that you want, but I recommend to do some negatives, some positives, and then always 0. So when you have your inputs, you're going to put them into your function. So inputs are your x values. So instead of x, you're going to put in -2 here, and then you're going to solve for the output. So here you're going to do f of -2, because that's what you're doing here. It's saying instead of x, you're putting in -2. So this is f of -2. This is written in function notation. So f of -2 equals 2 times -2 plus 4. 2x is 2 times x, and instead of x, we're putting in -2. So that's how we have 2 times -2 plus 4. And then you could do this mentally. 2 times -2 is -4, plus 4 is 0. So our answer here is 0. Let's do the next one. F of -1 equals 2 times -1 plus 4. So here we have 2 times -1, which is -2, and -2, oops, I put plus 2, it's plus 4. -2 plus 4 is +2. And then for 0, f of 0 equals 2 times 0 plus 4. 2 times 0 is 0. 0 plus 4 is 4. F of 1 equals 2 times 1 plus 4. 2 times 1 is 2, plus 4 is 6. And you're starting to see a pattern here with the output. Since this happens to be a linear function, it's going to increase by 2 each time. So that's how we're getting the 2, 0, 2, 4, 6. So the next one is going to be 8, but let's do the work just to make sure. So we have f of 2 equals 2 times 2 plus 4. 2 times 2 is 4, plus 4 is 8. So this is our function table for these inputs, and these are the corresponding outputs. And then we know it's a function, A, because this is linear. It's a linear relationship, so this is a function. B, every input is assigned to its own output, is another definition for a function. So this is one. Let's do another example of a function. This time, let's do something that's quadratic. Here is y equals x squared minus 3, or if we want to write this in function notation, we have f of x, which is just goes in place of y, equals x squared minus 3. So now, just give me a second, and our next function. So I picked some input values here, and if you notice I skipped -1 and +1, which is fine. You could use any input values that you want. So here we have, for -3, we have to square it and then subtract 3 from it. So we're going to square the input and then subtract 3. So we have f of -3 equals -3 squared minus 3. -3 squared is 9, and then 9 minus 3 is 6. And then we have -2 squared minus 3. -2 squared is +4, minus 3 is 1. 0 squared minus 3. 0 squared is 0. 0 minus 3 is -3. Let's do 2. 2 squared minus 3. 2 squared is 4, minus 3 is 1. And then 3 squared minus 3, 3 squared is 9, minus 3 is 6. And notice how the opposite inputs have the same output. That repeating pattern will always happen in quadratic functions because that's what creates the parabola and the symmetry on both sides. So here is our function table for this quadratic. But the next one I want to talk about is when you have a quadratic, but x squared is negative. So that could be really tricky. So let's try an example with that. So let's do example 3. We'll do f of x equals negative x squared plus, I don't know, 2. We'll do something easy. So let's create our function table, and you don't have to use input and output. You could still do x and y if you wanted to. So let's do that this time. Okay, here we have our function table for this quadratic. Now when you have this negative outside of x squared, you could think of this as a negative 1 times x squared plus 2, okay? So the negative 1 is on the outside technically. There's a big difference between having negative x squared and negative x squared. Here the negative is included, here it's not included. It's negative 1 times x squared. So when I have it like this, I like to think of it that way. It might be easier for you, but whatever is your own preference. I'm going to write all the negative 1s out here. And then I'm going to have negative 2 squared plus 2, negative 1 squared plus 2, 0 squared plus 2, 1 squared plus 2, and 2 squared plus 2. Okay, and then we could do the work for these. So negative 2 squared is positive 4 times negative 1 is negative 4 plus 2 is negative 2. Negative 1 squared is positive 1 times negative 1 is negative 1. Negative 1 plus 2 is positive 1. 0 squared is 0 times negative 1 is still 0 plus 2 is 2. And then 1 squared is 1 times negative 1 is negative 1, and negative 1 plus 2 is 1. There's that repeating pattern that we talked about before with the opposite inputs. And then lastly, 2 squared is 4 times negative 1 is negative 4. And then negative 4 plus 2 is negative 2. And again, there is the other repeat. So just be careful whenever you have that negative outside of a variable raised to an exponent.